So this video will look at different ways to shade and restrict your domain and help you shade as well. So up first, right here, I've got two circles, a smaller circle within a larger circle. One's blue and one's red. Notice if I, notice the color saturation that's there right now. If I change, and the red is below the blue in my order of my graphs, so that means whatever is below will be what is layered on top. It layers, so the order of your equations goes how they are written in order here. So if I change that order and put the red up top, now it means that the blue is over, right? That's the second equation, so that's going to come out a little bit more dominant. So that's one way to change colors or to change the shading on there. Another way is to notice if I click on here, there's only 6 colors to choose from, but you can start to change colors by layering the exact same graph on top of itself. So if I copy and paste the same exact equation and change the coloring and now come outside of it, the color in here will change based on whatever you've layered it there. So if I flip these around, now the blue is slightly darker in there. I can come in here maybe and change it to, how about if we change it to orange, right? So it does a slight variation in the coloring of it, but that's one way you could play around with if you're looking for a different color. In Desmos is how to create different colors. You could layer upon layer upon layer. But now probably what you're more interested in is how to change the shading domain based by a function. So we can come in here, let me go in here and add. I've already talked about how you can change the domain by just putting in something like this is going to be shaded where x is less than 3. And so here now you've seen that vertical line has come in here and it's changed the shading that way. So we've talked about vertical and horizontal changes in the domain, but you can also change the domain by another function. So here is, let me take out what I was already playing with. All right, so here is a big purple circle, and here is another circle inside of that. Let's say I want to try to shade just this outer ring of the purple part. I can restrict the domain by the domain of this second function. So if I copy and paste the black circle in there, and I then add my squiggle bracket, and then add that function in there. The only thing that's changed is that I see the small black circle, and again, think about what that means. I've restricted the domain here to actually just this circle. If I change the equal to sign to a less than equal sign, okay, it's still not helping, but think about what it again is doing. I am asking it to shade inside this smaller circle. Your outer circle is still here, but you've restricted the domain to just shade inside the smaller circle. So if I change this one more time to greater than, now we're getting what we want, right? I have the larger circle, but its domain is restricted to graphing everything outside of this smaller circle. I can play around with this one more time. Let's take out the circle domain in here. Okay, and I'm going to turn this off. And let's say again we want to restrict it maybe by a diagonal line. So what I usually do to come up with this is I find my equation first. So let's say something like y equals 0.5x plus 2. Right, so there's a line that maybe that's the line that I want to go through or I want to restrict my domain by. So right now, depending on whether I choose greater than or less than on my circle, I can either get only this top color here or the bottom color. And again, how do I do that? I would copy and paste this line. I would then go up to my circle, add the squiggly bracket for the domain restriction, add my new equation. Then you need to change this equals to either a less than if you want the bottom half of the circle shaded, or a greater than if you want that top part. And then again, if you don't want the blue line in there, which you probably don't, just come in here and hide that line. But that's how you can shade differently, either layering color upon color or by doing domain restrictions with other functions. And it really adds a lot of detail to your Desmos graphs.